Davis, what are you doing? Number 5. No. All right, so here's what we have to do. Davis, come on. All we have to do is identify the parent function. Identify the parent function and identify the transformation. So what's the parent function first off? That's right. What's that called? There you go. Uh-oh, okay.
It has brackets. I call it.
All right. What is this one doing? The 1/2. Uh-huh. Yes? And then the 5 on the end. Noah, what's the 5 on the end doing? Oh, 5.
I can do more than that. You have to give me
Give you a harder one?
Give me a harder one.
What else? Give me another one from your homework.
Number 16. What do you want?
16? Oh, this was Kaylin's problem. She shined on this one.
I'm not showing.
All right, so this one was hard because for this one, it's telling you that the function was already, this stuff was already done to it. So you're undoing the things that were done to it. So you have to think in reverse, okay? So it was stretched by a factor of 3. So if I undo a vertical stretch of 3, what am I doing? Divide it by 3 or multiply it by 1/3, right? So this number in front, I am going to divide by 3 because that's the opposite of timesing by 3, right? I'm undoing that vertical stretch. So now I have, shut up, y'all, negative 1/2 x plus 4 cubed. Oh, it's rude for you to talk while I'm talking. All right, Noah. I don't want you to feel like I'm only asking you the easy question. If I translate 5 units down, if I have already translated 5 units down,
5 units down.
how do I undo that? Shut up.
It's going to be a -7.
No.
You already said it. You add 5. Oh, good job, Noah.
Add 5, which gives me plus 3. Now I also have to reflect. I don't know. It's late. Are you hungry? Reflect across X. It's already been reflected across X. So to undo that reflection, all I have to do is drop that negative off. No?
Whoa.
Yeah.
I said it's late.
Later.
I said it's late. Why are you hungry?
Why are you taking away the negative? The negative's still there. It never says reflected back.
Oh, I looked at the wrong problem. I'm sorry.
How is it not -7?
7 units left. So if it went 7 units left, that's a horizontal, right? So that means I did add 7 here. So to reverse that, I need to subtract the 7. So now it's negative 1/2 x minus 3. Oh, I'm just showing you. That's how it's done. What else? I don't know. I forgot to. All right, y'all ready to move forward? Yes. It's funny you say that, Emma, because you know what today's lesson is? Piecewise. Did you know that? We watched your sister's video this morning in second block. No, it was her and Caroline. It was good.
The rap one?
She didn't rap.
Or the song one?
Yeah.
We rap. Did you play ours?
Can we watch Ben
I can't remember if I played y'all.
I got that one already.
So good.
You do ours, Miss McGee? You do mine?
Yeah, she stole my project. Or Carter Bates.
You do
What's
mine?
Carter Bates?
It's Bates' little brother.
What, Bates has a brother? I knew the sister, not the brother.
His sister?
Yep. I honestly think Charlie's might have been the best ever. Charlie's the best ever.
All right. While y'all are getting ready in Algebra 2, those of you who did not have me, I always just look right here because I know the three of y'all didn't, but did y'all do piecewise?
Wait,
It's the worst one. I better sit down.
it has a group of like.
Let me show you what it looks like. We're going to evaluate and graph. So stay woke. There you go. No.
I'm not. I thought it was just fun.
Literally, like, had this long. We had this, like, whole argument against us. She's like, all right, so, like, what do y'all actually. Like, oh, yeah, I think it was totally different. And he was, like, arguing against.
Yeah, I was arguing for that it was not.
She says our class sucks because we can't argue like y'all.
You have a pencil? You have a pencil?
Was it me or is it like really?
All right. Take a look at this function. Oh my gosh, could you please just write it? Wrote it down, please.
I haven't wrote it down yet.
I haven't. Right. Oh, that's correct.
You gotta go. Get it. Love the vocals.
Miguel, are you in for it?
You should be. Is that Diff?
Yeah.
Miguel, you want to join me?
Did you put this in the thing? Miguel, join Davis' band.
Did I?
Yeah.
Sorry.
Sorry.
I have a band.
All right, y'all ready?
I'm moving to New Orleans.
This is a piecewise function, and it's called a piecewise function because it's made up of pieces of different functions, okay? We know that this is an absolute value. That's one of the parents you have to know. That's a v, right? But it's only a piece of the v. It's only whenever x is less than -3. So wherever -3 happens, it cuts off everything before that, right? Or after that. And then this is a parabola that's upside down, but it's only the piece of the parabola that falls between -3 and 7, whatever that happens to be, and none of the other parts are on there. And then this is a square root graph that looks something like that, but only when x is bigger than 7. So none of this would be on there, just be that part. So it's all these different pieces that we kind of Frankenstein together to make one graph. Okay? Nobody does. I'm sorry. Because we have to. Oh, it wasn't as difficult in Algebra 2.
Can we like learn the algebra first?
You did in Algebra 2.
I don't remember.
If I asked you to find f of -5, my first goal here is to figure out which function that applies to. Why the first one? Right, because -5 is less than -3. It will only fit in one of them, okay?
Yeah, sure, that's all.
Okay, so this is my x, right? So I have to decide which equation it matches. In other words, these restrictions here. Is -5 less than 3? Is it between -3 and 7, or is it bigger than or equal to 7? And it's this one because it's less than -3, right? That's -5. So that tells me that I'm going to plug into this very first equation. So f of -5 is going to be 2, absolute value, -5 minus 5, like this. No, for real. Throw it away if it's out.
So, how do you do that? Why'd you circle the numbers on the right?
Because that's what you have to look at to decide which equation you need to use. Okay, so then what do you do after that? Well, -5 minus 5 is what? -10. What's the absolute value of -10? 10, and 2 times 10 is 20. Y'all okay there? All right. How about if I asked you to find f of 2? Don't blurt it out. Don't blurt it out. See if you can do it on your own. Ooh. I literally just had one I was using. All right, which equation did you use? The second one, right? That's half the data is determining which one I need to use. Okay. Yes, so that tells me that's the equation I'm using.
So it's going to give you, so the questions are going to give you 3 different.
It could give you 10 different f of x's. You have to decide which one it fits.
If it's
Yes.
the left or the right one, or if it's
1, 2, 4, 3.
so they're all going to go into the right.
Left side. All right, so f of 2, I decide which restriction it goes with, right? 2 is between -3 and 7, so I'm using -x squared plus 4x. So -2 squared plus 4 times 2, which is -4 plus 8, which comes out to be 4. Everybody get 4 for that one? It'll be here soon. Yeah. You have what? I bet they don't have that again. What if that's what made your eyes do that? What if you're allergic to water? Oh, okay. The middle one. All right, f of 7, try it. Mark, set, go. Don't blurt it out when you get it. F of 7. Is it? It is not CBF, Davis.
Oh, wait, I got it.
This one has a...
Yes, you can. Go ahead, McGill.
Yo, you don't have to put it up.
No.
Dude, you don't have to yell it out, bro. Don't yell it out.
Plus or minus?
Why did you yell this?
Okay, so on this one, let me tell you why it's not plus or minus on this one. It's a function. If you think about what a square root graph looks like, we only take the primary root whenever we graph square roots. And the reason is if we took the negative root, we wouldn't have a function also. So when we're talking about functions, we only take what we call the primary root, which is the positive root. So we don't need the plus or minus there. I broke this down. Did y'all not talk about that? No. Okay, so if you have a square root, you want to find the biggest perfect square you can divide that by. In this case, it's 4. 4 times 5 is 20, and so I put both of them with a radical. And so it simplifies to 2 square root of 5. You're always looking for the biggest perfect square to divide it by. Yeah. All right, let me give you a harder one.
This lesson's gonna be short.
No.
No.
We haven't even graphed them. Right now, we're just evaluating them.
They're not that hard to graph. It's just between which x values.
They're not unless you get into a situation where you have like a vertex or something that you have to include.
From the first time.
I like that.
I'm going to give you 3 to find. This says it doesn't matter. As long as x is between these values, my y is going to equal 8. 3.1. Which one does 3.1 fit in? The last one, the greatest integer. So greatest integer of 3.1 minus 4. So this is the greatest integer of 0.9, negative 0.9. If I go down from negative 0.9, where am I? Negative 1. Think about a number line. Here's 0, here's negative 1, negative 2. If I'm at negative 0.9, going down goes to the left. The closest one below it would be negative 1. Always down. Always down. I drew a number line in calculus this morning to help us with something we were doing. Negative 8. Which equation? The first one, because it's smaller than negative 4. So I've got 1/2 negative 8 to the third plus 7. Davis, what's negative 8 to the third? So what's 216? No, because I was dividing it by 1/2 though. 256. Not really. Yeah. Boy, I'm just failing today. 249. Y'all ready for the hard stuff?
Yeah, I don't have a pen.
That's good.
I need a blank.
You're not ready for it.
Am I allowed to give it to him? More graphing.
Yeah, we said to figure out stuff on the road.
What?
Oh my god.
Unpopular.
Wait, for who?
I'm subscribed to this week.
Give me a sec.
All right.
Actually, it says.
Oh.
You know, sometimes I wonder what they're going on. I could have told you that. I'm not in a bad way.
Now, when we did these in Algebra 2, Logan, we mostly dealt with linear. All right. In Algebra 2, we dealt mostly with linear and quadratic. Now we're adding other stuff to it. Now let's think about this for just a minute.
I was going to Khan Academy.
And then he got bored.
All right.
You're looking at me for it.
How much longer do we have?
Where are y'all from? You like my picture?
I charging over there, Miguel.
Thank you, Miguel. You should be in charge of that every day, helping me remember about the phones. That can be your job. All right. Think about the. Think of.
That's good. I don't know why y'all hate it.
Think about the absolute value. What's it look like?
Say what? Absolute value.
A V, right? So this is going to be a V going up, but it's been shifted which way? Down and left, okay? Left 3, down 1. Everybody okay with that? All right. This is just a line. Starts where? -5, and then the slope is 2. Up 2 over 1, yes? All right. Let's see what happens when we graph it. Now, I prefer to start at the, in fact, I always do this. Start at the point where I'm cut off. Okay, so the point where I'm cut off is 0, yes? So if you plug 0 into this equation, think about it like a T-chart like this. If I plug in 0, what do I get back out? 0 plus 3 minus 1. In other words, what is f of 0? 2, yes? Now, is that point included or excluded? Look carefully. Why is it excluded? It's just less than, right? So what that tells me, because it's less than, that's telling me an open dot at 0. Okay, so I've got this point 0, 2, 0, 1, 2, and I've got an open dot. Everybody okay? Yes. Right. Now, I have to include all pertinent information as I graph this. In other words, if it's an absolute value, I got to make sure that I pick up my vertex if that falls within my range of numbers here. So here, this says go less than 0. So I need from here all the way left. Well, what did we say this graph looked like? It was the absolute value, but it slid left 3 and down 1. This is my new vertex, yes? I have another point, so I'm going to connect that. But I need to have it going in the other direction as well. Why what? That is the parent graph that has simply been slid left 3 and down 1. If you remember graphing absolute values and you graph them from vertex form, because on the parent, it hasn't been stretched or shrunk any, so it just goes up 1 over 1 from the vertex. Or you could reflect this one. 1, 2, 3, 1, 2, 3. Yes, that's going to be a filled in dot. You can either reflect this point over the middle, or from the vertex, since there's no stretches or shrinks on it, you can just go up 1 over 1. Think about that parent graph. This one I got just knowing what the parent graph was. This one I got because I reflected this point over. Not at -5. I'm still starting same x, right? So look at this one. It still says to start at 0. So if I start at 0 here, what's my y point? -5. So 0, 1, 2, 3, 4, 5. Is it open or closed? Closed this time. So here's this one closed. And now I need to go to the right. Well, this is just a line with a slope of 2. So I'm just going to go up 2 and over 1. No, because that's where it's cut off. There's no more graph past those. This first one, right. Now, I say all that because we're going to have to do a little analysis. What's the domain of this entire function? All real numbers are negative infinity to infinity. The grown-up way to say it.
Guess what?
How did we get what? That's this line, but only when x is bigger than 0.
Can I explain why?
Sure.
Because that first equation makes is always going, it doesn't go down further.
That's what I got.
That. All right.
All right, left to right. As you move left to right, there's always graph. I will sometimes take my pencil and start on the far left and keep going right, and I will always be touching some point on the graph. There's never a time where I won't touch any graph. So it's negative infinity to infinity. But the range goes from the lowest point up to the highest. So what's the lowest the graph ever goes in terms of y? -5. Is it included or not? Yes, so it's a bracket. And then as I go up, well, this end goes up forever, so I don't even have to worry about anything. It just goes up to infinity. Yeah. No, not on this one.
That's inequality.
Wait, but it starts at the bottom.
It's gonna be okay, guys.
Right, that's why it's -5 up.
Oh.
Yeah.
No, it doesn't start at the bottom of the graph.
Is this a continuous function? Why?
Continuous and a jump.
It's discontinuous. It has a jump discontinuity where?
At 0.
At 0. I have a jump discontinuity at x equals 0. Because this is where it happens, and I always use x to describe where. Go get the papers off the printer and give everybody one. I'm going to do one more with you if you need it. If you don't, Logan's going to bring your homework paper around, and you're welcome to work on it. Well, no, it's half and half, I think. Yeah. Yeah, you got 1, 2, 3, 4, 5. Yeah, half and half. There will be, not today. Which is generally the goal, because I don't like y'all to have to go home. I'd rather y'all do it here. Black? I love your red hair. Don't apologize. You can. Let's do this one. right, let's graph this one. All right, let's do the first one. What does the graph of y equals 7 look like? It's just a horizontal line. That's all it is, at 7. So this is saying when x is negative 1, 1, 2, 3, 4, 5, 6, 7, inclusive or exclusive? Yep. All right, so at negative 1, I have an open dot because it's just less than, and it's less than negative 1. So it's just that horizontal line, but the piece, it starts at negative 1 and it goes off to the left. That's it. The graph. So, okay, if I graph the line y equals 7. Okay, pretend like that was on 7. That's the line y equals 7. You agree? But then this says, wait, it can only be y equals 7 when x is smaller than negative 1. Well, here's where x is negative 1. So it can't go past there. So if it's smaller than negative 1, it's only on this side. So it can't be any of this. All right, let's do this one. This one's nice because it sits between two numbers, so it's got two endpoints, okay? So let's think about, remember what that cubic graph looks like? So a cubic graph, the parent graph, starts at 0, 0. It goes up 1 over 1, up 1 over 1. It does this, but it curves this way. The concavity changes. That 0, 0 is a point of inflection for that, okay? So for x cubed minus 1, the only thing that's happened is what? It shifted down 1. That's it. This is still the middle. So this is happening between negative 1 and 2. That's all I want. That's the part of the graph. So what I'm going to do, I'm going to plug in. Okay. If I plug in negative 1, what do you get? Negative 2. This endpoint, I need to know where to go with this one. Okay. So negative 1, negative 2. My vertex, my point of inflection was originally at 0, 0, but I have slid it down 1, so now it's going to be here. And the other point I need is the other endpoint. This is what I was talking about, including those critical points. I need that point of inflection for a cubic, so you got to make sure you include that. I need a vertex for a quadratic. I need a vertex for an absolute value. I need those important points if they fall within my range of numbers. All right, if I plug in 2, what do you get? 7. So that means 2, 1, 2, 7, open or close? Close. That's my other endpoint. So whereas this was the whole graph, the piece that I have now that doesn't look quite right. How did I get what? That is my original vertex is at 0, 0, my point of inflection 0, 0, and I just went down 1 because that's what that graph is. So it took that cubic, it slid it down 1, and then cut the end parts of it off. Y'all okay? Now the last one. It's what I think is the hardest one. If I plug in 2, because that's my endpoint. Now, first of all, think about what a square root graph looks like. What's the parent graph look like? A little line, like that, okay? What's being done here? It's been reflected over what? That means it's going to be going down now. What else has happened? Up one and a horizontal shrink. Okay. Now that I know all that, I kind of have an idea of what's going on, right? At 2, if I plug in 2 here, what's my Y value? -1. Open or closed? Oops, that's not -1, that's -2. It's just greater than. All right, so now I need to pick an X that's bigger than 2 because here I could slide this or do whatever, but it's easier for me on some of these that have the shifts and the shrinks and the stretches if I just pull in a number that fits in there. Because there's not any, other than the endpoint, there's not really a key point in a square root graph, right? What's a number bigger than 2? 3 or 4, it doesn't matter.
100.
Okay, but we've got to be able to graph it. Maybe pick something that's going to give you a perfect square. 8 would. But 8 times 2 is. So that'd be 16. Square root of 16 is 4. -4 plus 1 is. I'm plugging in this. You can pick whatever X you want to as long as the X you pick is bigger than 2. If you don't pick a perfect square, then it's going to be a decimal. But it doesn't matter. 1, 2, 3, 4, 5, 6, 7, 8. What's your situation? Oh. Yes or no? What's the domain?
Oh, I didn't know.
Is this still a function, by the way? Yes. They're piecewise functions. Every place that they sit directly over, one of the dots should be filled in and one not, because to maintain its functionality. Range. Oh, range.
No. Don't doubt it.